Ashley, this is Jane, and this is Alan. And today we're going to be talking about hydrophobicity and also hydrophilicity, which is basically, so hydrophobicity is the property of a substance being water-hating, and hydrophilicity is the property of a substance being water-loving. So hydrophobicity and hydrophilicity are very important and seen in common uses in medical situations, and there's even planes that that incorporate hydrophobicity to not get frosted, and there are also, and even in clothing such as raincoats and shoes that are stain proof.
So before I talk about this picture and analogy, I just want to, highlight 2 points. So how water interacts with the surroundings, especially a surface of material is depending on mainly 2 things. The first thing is the chemical functionality, meaning that if or not the water and the other material has similar chemical properties. And the other thing is if the surface has nano roughness, meaning that if on the nanoscale, if the surface has many bumps and a lot of surface area. So if water and the surface have the similar chemical functionality, then the water tends to be hydrophilic, meaning that the water wants to stick on the surface. So imagine on paper, if it's hydrophilic, then the water tends to spread on the surface. So one way where we can measure this is through the contact angle, meaning the tangent of where the water meets the material. For a hydrophilic material, it's usually a very small angle, and that's the opposite for if the surface and the water has very different chemical properties, then the water tends to beat up because it's kind of repelled by the surface. So in this picture, this part is kind of this picture shows basically how people interact with pigs and porcupines. So in this picture, this girl is hanging out with these pigs and they are getting along with each other. So, and especially so from here we can see. And because they are they are getting along well with each other, so it kind of shows that it's an analogy to just the normal hydrophilic interactions. And we can see also from this picture that because there's a arrow here, it kind of symbolized it's have a small angle. So for a normal hydrophilic surface, the water tends to spread on the surface, but it's not completely spread out on the surface. And so if you have some nano roughness, meaning that you have a lot of surface area, in this case there are 2 pigs hanging out with this guy and they are getting along well. So I guess this guy is kind of, I don't know if it's lying on the ground or anything. So it kind of shows this is the super hydrophilic example, in analogy of how people interact with pigs. And for the hydrophobic part, and we can see this the porcupines and this person is kind of, they're disturbed, I guess. And there's also an arrow here symbolizing that the water is the people is kind of bending outwards. If you think about if that's a water droplet, it's kind of it's speeding up. So that's an example of the hydrophobic behavior. And on this example, this girl is curling up, and it's similar how a water droplet would behave on a lotus leaf or anything. So the water beats up on this kind of hydrophobic surface. And there's also 2 porcupines, meaning that there are little bumps on the surface, and there are 2 of them, so more surface area, I guess. And also the porcupines have spikes on them, so it's also, I guess, shows the nano roughness which is required by the hydrophobic surface.
This picture is really nice and cute, but I have one limitation is that besides roughness, we need chemical functionality, which is about polarity. When two things are the same polarity, they tend to stay together, and when they have different polarity, they repel each other. So I think we can represent that by like same gender of the animal and the person. So when they are same gender, they like each other. When they are different gender, they dislike each other.
So it has to. I think it has to do with like the structure of the surface. Imagine if that's a surface, and if it's like super flat, and if it's hydrophilic, meaning like if the chemical properties is similar, so the water still has a lot of contact areas. But if there's a lot of bumps on the surface, so what the water drop is actually in contact with the surface, it's actually very small. And if it's hydrophobic, so and the air that's trapped between the bumps is also kind of making the droplet a spherical shape. That's why the water beads up. And if it has like some structures on the surface and it's rough, and then if it's hydrophilic, then the water has more surface area to stick on the surface. So like so basically the roughness of the surface make the hydrophilic more hydrophilic and hydrophobic more hydrophobic. Yeah.
So one thing I see here, so we've got, so for the hydrophobic and hydrophilic, we've got one animal, and for the super, we've got 2 and 2. But one other thing I noticed is that the porcupine actually, he does have more surface area when it's super hydrophobic, but the pig, I think, kind of has the same surface area, even though there's 2 of them. Is there maybe another animal that you could think of that could have a high surface area as well? Similar to how the porcupine is rough, is there like a rough animal that would be like nice to pet that would be hydrophilic?
I guess like a turtle would kind of be.
I want to meet your rough turtle. Chinchilla. Yeah. Okay, I'm going to ask a different version of a question. So what you explained is very good. It's correct in terms of the way that roughness amplifies hydrophobicity or hydrophilicity. If you're hydrophobic and you're rough, you will not wet the whole surface, so you're really just going to touch the tips of the roughness. And so then you have a surface you hate and you don't have much surface area. And if you're hydrophilic, you're going to wet all of that hugely increased surface area, and so the droplet is really going to spread down. So that's a concept that's not captured in this picture. And so now my hard question, and I don't have an answer, is how could you start to capture that concept? And that's the hardest thing. Nobody's pictures, not across all the camps, not just this one, have been able to capture that concept in a picture. How might you start to modify that to think about getting any aspect of that concept in this picture? I could think of, there's some ways you could modify this picture.
So I don't know if that really makes sense, but so for the pig, like you kind of can like hug over it. So you have like a lot of more surface area to be intimate to the pig.
Yeah, no, exactly. Exactly. You could be and you could be not hugging or just touching the tips of the spikes of the porcupine. And so that concept of really touching the surface area in the hydrophilic case and not touching the surface area in the hydrophobic case could actually be incorporated. In many cases, once you start really thinking about it, you're like, oh, wait, I could change it. I could add this concept. And that's when you're really making cool science analogies. So good job.